All right, so now that we've introduced the structure of molecules, their geometry, and we've talked about whether they're polar or not, now we're going to start talking about bonding. We're going to come back to this. Now this is going to look familiar to that kind of chapter 7 review that I filmed earlier. In fact, I have the exact same example here. But now you can see it through a whole new set of eyes because we talked about all these other topics. So the idea that we're going to present first is called valence bond theory. And so this is just the idea that chemical bonds are overlaps between atomic orbitals. So that shared space between the overlap of two atomic orbitals is where the shared electrons will be. And the more they overlap, the stronger the bond is going to be because there's more space for those electrons to be shared in. That should be more stable. So that's the idea behind valence bond theory. And so an example here, H2, well, you know, we've got a 1s orbital. This is our first hydrogen. We have another 1s orbital. That's our second hydrogen. And then we get this overlap here. We'll label these nuclei just H's, I guess. There we go. And so this overlap, that's our shared electrons. That's where they're going to be. So this overlap region holds our shared electrons. I.e., that's our bond right there, right between our two hydrogens. So this is the most simple example we can do. Doesn't get any more simple than hydrogen. It has just a single 1s orbital. So what about, you know, what about when we're using p and d orbitals? Well, that is going to be more complicated. So this is more complicated. And that's going to be what the next video is about. Because this is called, we'll move it down here, hybridization. So essentially what we're going to do is we're going to mix them up. We're going to kind of shuffle them together and make new orbitals out of them that we use in bonds. And we'll talk about the shape and everything. I'm going to do a screen capture video for that because I want to show some 3D stuff again, bring structures back into it. But valence bond theory ties right into hybridization. Its overlap of orbitals gives us a space that's shared, that we can share electrons in. And if we look at our H2 example, we would get a linear geometry here. They'd just be right next to each other, which is exactly what we would predict based on our Lewis structure. We have one electron group. It's got to be linear. How are you going to get any sort of bend or shape in there with just one other group? And so it works. And that's what is behind all of valence bond theory and hybridization. And that's going to be kind of the trick, is it's essentially just looking at the reality of what these molecules are and then trying to match that theoretically by mixing up these orbitals. We'll talk about it some more in a little bit. The more modern best approach is very similar to this. It's just kind of scaled up another level, but we won't get into that in this class. It's just first year chemistry. But just a heads up that like this idea isn't totally harebrained. It just turns out that there's some extra details we have to account for later. All right, so this will be used to explain our geometries, and it's just getting orbitals to overlap. It won't always be s orbitals. Oh, you will see. All right, so we'll just continue through chapter 9 with the next video.